Hello, everybody. My name is Bob Heubel, and I'm with Immersion Corporation. And I'm here to talk today a little bit about mobile games. I've been in the industry for 13 years now, looking to improve the user experience in games, and specifically mobile games now. And what I'm going to be talking about is the Vibrate function within mobile devices, and how it's been used in console gaming and now in mobile gaming, and how we can take that experience from the console knowledge that we have and now bring it to the mobile platform. Now, Immersion, where I come from, is a haptics company, and haptics is about the science of touch. This is about tactile response. We've been around since 1993, and the company is really an IP company. We come up with the ideas, the recipes that make our partners' products better. So like the Sony PlayStation or the Xbox 360, these are hardware platforms that we have helped our partners with to give that tactile rumble feedback in the gaming platform. And now in the mobile space, we're doing the same thing with our partners Samsung, LG, Toshiba, Fujitsu, many mobile partners like Motorola. And what we're doing is enabling them to use the motor that is in their devices for more than just touch feedback, but for gaming as well. What you see here are some of the devices that our technology is in. We are in more than 1 billion devices from our partners. We don't make the products, but we make them tactically better, the haptics with inside better. So meet this little guy here, Homunculus. He is the mobile user. What this is showing is a representation of our sense of touch across parts of our body. You'll notice that the hands on Homunculus here are huge. This is why the mobile tactile feedback experience is so important, because this is how we interact with our world. And now the mobile space has become our virtual world. So all the experiences that we get on a daily basis is through our sense of touch. And what has happened with the cell phone and tablets currently? They've become slabs. We've gotten rid of the button interfaces that are there. They're now virtual interfaces. But we still need that sense of response that we're used to in the real world. So that's why we're trying to bring this back into the mobile experience. I'm going to show you a little demonstration here. This is a pinball game, obviously, but what you have here is interactive pinball. And when the ball is on one side, the user can feel the motor within inside this device. You can feel the ball bouncing around. But what's unique in this experience is that when the ball goes off onto the other device, the first user can still feel what's happening on their device, so they can anticipate where the ball is and where it's coming back from. A nice user experience. Now, things that we've learned from the console gaming space are that people like to have the feedback. They like the rumble effects. They like the racing games. For example, here you've got the Xbox where they've got Halo, and you can feel every weapon in that game when you're in a firefight. The machine gun feels different than a rocket launcher or a pistol or even just melee combat. You can feel that on the console platform. And games like Gran Turismo, being able to feel a real simulation, racing simulation, where you can feel if you're drifting in a turn or if you're colliding with another object. Or something like the Wii platform, where you've got Legend of Zelda, where you can feel that you're galloping virtually on this horse, or that you've caught a fish on your line, or that you're pulling back a bow and arrow. All of these sensations on the console platform are possible now in the mobile space. This feeling of being there, more tangible gratification, making it feel more realistic. All of this that we've learned from the console space is now possible on games like Max Payne for mobile, or Grand Theft Auto, or Sega's Sonic. And I'll show you some examples here. Recently, Rockstar started porting a lot of their older titles like Grand Theft Auto 3 and Vice City and Max Payne Mobile. And they wanted to have that experience on the mobile platform mirror what they did on the console space. So what they did was every weapon that's inside that game that Max Payne is firing feels unique. It feels different. A machine gun feels like a machine gun. It has that repetitive pulsing that's going on. A shotgun blast feels like a single pulsing, very strong effect. When you're driving in Grand Theft Auto, if you have a collision with that vehicle in your mobile device, you're going to feel it, just like you would on the console experience. In games from Sega, they have titles from Sonic, their Sonic franchise. And in that game, they wanted the user to be able to feel all the bounce pads in the game. They wanted you to feel all the power-ups that were going on, all the spinners, all the little destructive things that you do in the game as well, to make you feel more engaged in the content. And that's simply by using the motor inside the currently existing devices. In games from handy games, and you may not know about handy games, but they've been around for quite a while, and they have many, many downloads. You should check these guys out. Games like Clouds and Sheep, it's a very interactive, kind of social feeling game where you are controlling these sheep. You're having fun tending your flock. You can pick up the sheep, toss them in the air. If there are rain clouds coming over, you can break up the clouds. If there's thunder and lightning, you can actually feel that in your fingertip in the experience. In something like Farm Invasion, there was a lot of interaction going on in that game, but they didn't want it to be rumbling and shaking the whole time, so they're very sparse on how they used the tactile feedback effects in that game. The best experience, I'm going through, I've got this guy in a tractor that's mowing down aliens, and I'm not even noticing that this flying saucer comes overhead, but all of a sudden, he's trying to lift me off my tractor. And I feel this little subtle thump, 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 as they're trying to pull me off the tractor. And all of a sudden, my attention is pulled to that part of the screen in the game as an alert, as a notification. It was a great moment in that game for me. It was really nice. So it doesn't have to be something that's really in your face, strong, with a tactile experience. It doesn't have to rumble and shake a lot. It can be very subtle on a mobile platform. So I'm going to give you 5 reasons here to use these sorts of tactile gaming effects. Of course, it's what we expect from the console experience. It gives you this sense of being connected to your content. It's more like the real world that we know. It also, when combined with audio and visual events, becomes what we call a multimodal experience, where the combination of these 3 modalities becomes greater than any one separately. It's greater user satisfaction. Remember when PS3 came out, they got rid of their rumble pad, their DualShock technology, they got rid of it. They said, you know what, we're going to maybe save some bucks here, and the users don't care about it much. 6 months later, they put it back because the users were missing that experience. So we know there's value there. And the stickiness, if the game feels more compelling, more realistic, you tend to stay in the application longer. But, of course, the #1 reason that we want to have these sorts of sensations in our games is for more potential revenue. And how does this happen? Well, on the Android platform, not just the Android platform, but everybody's looking to have an edge, to have something different than everybody else, right? So if you're going to put this kind of sensation into the game, the OEMs are going to pay attention to it. And I can tell you from experience, especially on the Android side, that Samsung, LG, Toshiba, Fujitsu, all of these guys are looking for tactile content. And the reason is because the iOS platform doesn't currently support the vibration technology in their applications for developers. So they are actively looking for polished content that they can use for their Android platform, their new hardware that comes out all the time. So if you do that, you have an in with the Android OEMs. Doesn't mean it's going to happen, but you have a better possibility. Okay, so I'm going to talk a little bit about how to actually program some of these events into your game titles. Okay, iOS does have a vibration control mechanism, but it's no good for gaming. It's meant more for alerts, for notifications, a very long buzz with no control over magnitude. Android offers a vibrator class with on-off duration times that you can set in milliseconds. Okay, that's fine for clicks, confirmations, and notifications like buzzing, but it's not really good for gaming. If I want to do some pulsing or I want to control the intensity, it doesn't really work so well. But because Android is an open platform, we can extend it. And that's what our company has done. We've extended the method, and I'll talk more about that. BlackBerry, Windows Mobile 8, Bada, they all have control mechanisms for vibration. So if you're using one of those platforms, you can go in there and add some tactile effects to it. And you'll get a better user experience for your users. Now, I said that the Android platform is extendable, and it's nice that it's very open. I wanted to give you some statistics here. There are over 600 Android device manufacturers out there, 600, with more than 7,000 models. And this is at last count of handsets and tablets out there. They all have vibration. They all have motors inside of them. And it's the greatest opportunity for making use of this tactile experience over Bada or Windows that isn't quite as open right now. It doesn't have nearly as many devices out on the market. So what we did to help support the gaming initiative, because remember, our background at Immersion is from gaming. So the first rumble pads, the first racing wheels, all of that, the first force feedback joysticks, that was Immersion. And we want to keep that experience going on the mobile platform. So what we did was we created a free library for developers to use on the mobile platform for Android, because it's the quickest, easiest way to get started. So like I said, with the Google Vibrate command, you can control duration. So you set a time to have the motor turn on and turn off. It's not that helpful. So what we did was we capture that command, we run it out to our library, and we bring it back, allowing you to control magnitude, frequency, pulsing. You can make your own timelines. You can associate with sound, and you can do dynamic API control of these parameters. So say I've got a racing game, and I want to feel as I'm accelerating and decelerating based on the speed of my vehicle in the game. I can do that with our free API in Android, but you can't do it with the standard Google Vibrate command. What we also offer is pre-made effects. So if you want a shotgun blast, or if you want to have engine vibration for your car, and you want to feel a different vibration when you're on a smooth road versus a bumpy road, you go off-road, it gets bumpy. All of that's predefined in a library of 124 effects. And I've got an application here where you can experience that. This is free on Google Play. I'll pass it around for people to try. And so now, folks like Rockstar and Sega, they can pick from a list. They don't have to design anything. They say, I want an effect that should feel like this. Okay, I pull it, it's a 54, put it into my code. And they're done. For Rockstar's Vice City mobile on Android, and this is a best case scenario, they were able to add in all the effects into that game. Every weapon, every collision, every interaction in the game that they wanted to feel, they were able to do that in 24 hours. Now, for a large game port from console over to a mobile platform, that's pretty astounding. And the reason that they were able to do it so quickly was because they're pulling from a predefined list of effects. Very simple to do. Now, down at the bottom here, you see it says, most consistent feel across all Android devices. So what we did with our SDK and these pre-made effects is we compensated for the differences between the Android devices. Some devices have big motors, others have small motors. They're all different from the manufacturers. But as a developer, I don't want to care about that. I want to be able to pick an effect and have it feel consistent across all the devices. So that's the real beauty of the immersion extended vibration method. You see here are photos of different types of vibration motors that you find in your hardware. So some are eccentric rotating mass motors, that are very similar to what you find in DualShock. It's the same technology. You have linear resonant motors that are vibrating up and down a mass on a spring at 175 hertz. And you have the latest technology, which isn't actually a motor, but it's called piezo. That's that bar-looking black bar motor down there. What that is a crystalline element that when you apply voltage to it, it flexes very quickly, and it has a wonderful frequency range. So you can use that, and you'll find that in the most recent tablets and handsets that are coming to the market today. Immersion works with the OEMs from the prototype level out to production, so we know the latest motor technology that's coming out, and we can support it with our SDK, and that's what we're doing today. So this haptic effect preview app that has all the predefined effects is essential if you're developing a game on Android. You can try out all the effects and how they're going to feel before you do any programming. So this saves you a lot of time. You don't have to make the durations into your application and recompile time and time again. You can see what it's going to feel like with this application and then program inside. So I'm going to pass this around real quick so that you can experience yourself. And if you wouldn't mind, just pass it around after you've had a chance to try it. There are many different categories of sensations in this effect preview app. So you have things like UI confirmations, button presses like QWERTY, or even for your menu system. You have buzzes for alerts. You have ramping up, ramping down. You have weapon effects, like I've talked about, motor effects. You even have vibratactile textures. Imagine if you have a drawing application or a painting application. You can simulate the feel of the surface drawing or painting on canvas. It's built into this pre-made application in our SDK. We also have a quick start guide. So I'm going to walk through the steps of the quick start guide. It's right here, and we have a bunch of them in the back of the room. So if you're a programmer and you want to see how easy this is, you can take this with you, and it has all the links as well to download the free SDK. So there are two major components to the library that we have. One is a jar file, which is only needed if you're doing Java code. So if you're not doing Java code, you don't need that. But the other part of our library is what we call this emulator.so file. And that is to make sure you have compatibility across all device types. That's when I was talking about having a different motor in each type of the devices. Well, you want to have compatibility across all of them. So you want to make sure that you put that into your libs ARM ABI file. And if you don't have that file, you need to create it. And this is the basic setup within Eclipse on what you would have to do. And all of this is in the Quick Start Guide on navigating to your project properties build path, and if you are using Java, to add the external jar file. And most importantly here, you want to, in the Permissions tab, give permission for the Vibrate. If you don't have the permission for the Vibrate on the motor, then you're not going to feel anything. Okay, so the first thing that we do with enabling the predefined effects that we make, you have to have a launcher class. So this is the little mechanism that's going to go out to our library and come back with the effect that you want. So you get that launcher class made, instantiate it, and then you want to use the effect preview app to choose the sensation, the tactile effect that you want to play back at that particular point in your game. Once you have identified that, you go ahead and you put it inside the play effect call. And you'll see there that what we're saying is launcher play bounce 100. And that's going to be a bounce effect, say like a bouncing ball. And it's set to 100 for the strongest voltage to the motor. So that's 100% voltage. And once you're done with that effect, all you have to do is stop it. Now, I also want to note that you'll see here it says catch runtime exception. That's just good programming. You want to make sure that there's nothing else going on that might interfere with what you're doing with the play and stop effect calls. For example, a system vibration call. If you've got a phone call coming in and it's going to turn on your motor and you've got the event inside your application, your game, where you're also calling Vibrate, you don't want there to be any exception there. And so if you understood the last 6 slides, that's really all you have to do to trigger a vibration call, a tactile effect within your application, whether it's a game or any other application. It's very simple code. But I want to also talk about things that are not games. So yes, Sega and Rockstar, all these guys are using this for their games, but this is another communication channel to the user. So yes, the user uses his eyes to look at the screen. He's using his ears for any sound elements that you have in your application. But you can give information to the user through their sense of touch that you can't do in any other way. So let's look at a couple other possibilities for using your sense of touch and this motor that's in your devices. So screen gestures, the things that you would do with sliding, swipes, pinching, twisting, expanding, all of those you can give confirmation of that gesture back to the user through the motor. And I'm not talking about buzzing. And when you try the preview app, you'll see that you can be very subtle responses. And when I was looking at the Intel, what they were doing for their perceptive work, I wanted to see, is there a mobile way to do this? Can I use this gesture recognition that they have on a mobile platform and also get some confirmation of the gestures that I have? So we have the effect capability there. The motor's in the device already. So if you have an application with gestures that you're using on screen, you can give some confirmation of what's going on there. Think about social networking. Facebook has a poke, right? What is a poke? It's a message. No one's actually poking you, but in the mobile platform, you could have virtual poking, or kissing, or hugging, all using that motor and using the effects that we have in our library. There is a heartbeat effect that you could use for love. Send somebody a heartbeat message. Nobody's done it yet. It's possible. Think about children's learning, just to keep kids in tune with what's going on. Maybe there's a handwriting course that they have to take and they have to trace within the lines. You could give them some feedback on when they're doing something correctly or not. Think about two-way interactive videos, and I'll show you an instance of that. But the first time I conceived of this, I was on my first business trip in Europe, and I had a young son that would give me a kiss goodnight, and I was missing that. So I was like, well, wouldn't it be great if I had my phone here and I could pick it up and I could hold it to my cheek and he could give me a virtual kiss? Why not? We can do that. There's a little motor inside there that could give me a confirmation that he has touched the screen on his side, and through that, I'm getting a response on the other side. Think about customizable alerts. You go to a movie theater, somebody calls you, and it's in vibrate mode. That's fine. Okay, you've got a call, but you don't know who's calling. If you can associate a pattern with a group or a person that's calling you, then you know who it could be. It could be a heartbeat for your wife. It could be an explosion for work, but you can identify it that way. Apple's already doing this in their notification system on their phones. There's a couple of developers that have an application like this that you can download from Google Play. It's just using a different communication channel. E-readers, what if you could feel the page turn in that application? Or what if you had the words within what you're reading had some content to that? Say you're reading it, you've got your finger going over and saying, it's a light rain begins to fall. And all of a sudden you're feeling these little raindrops in your device, just through the motor that's already existing there. That's possible. Applications for the sight impaired, we put together an application at a hackathon where it's a virtual clock. And when you run your fingers around the virtual clock, you could feel the hands on this virtual clock. Handed it to 2 different blind people. Within a second, they both guessed the right time based on the feeling of that clock. Nobody had done it before, but it was just a little pop, a little click to give a confirmation of where the hands were on the clock. Nobody else had done that yet. Very simple to do. Sport health apps, if you're trying to keep a cadence, you could use it there as well. Nobody's done that yet. So I want to leave you with a couple of videos here. Here's a little video clip. Shannon comes up. She knocks on the glass, and I feel that in my hand. You can have two-way video conferencing where you have an experience like that. Now this here is an example that is very similar to what I'm talking about, where my son would be on one side, I'm on the other side, and I can experience the other user. So here, one person is drawing, and then the other person is drawing on their side, and when the traces connect together, you feel a virtual touch effect. And here's the haptic clock that I was just talking about. So I'm going to leave you with a couple of links here and a little bit of information about how large the SDK is. There's a quick start guide, the preview app. It's all free. We make our money on the hardware side from the OEMs like Samsung and Logitech and LG and even Cadillac. And we do have plugins. If anybody's using Unity, we've got a plugin for Unity. And if you're an iOS developer, I really would think that you might want a little porting effort here to maximize your revenue like Glue and Rockstar and Sega are doing. Just because you can make money on iOS doesn't mean you can't make more money on Android. There are so many devices out there, so many OEMs that are looking for great feeling content. And I want to say a quick word about power consumption. Okay, a lot of people think that the vibration motor uses a lot of power, and it really doesn't. We've done power tests, and we have to do this with the OEMs anyhow. But 2 hours of gaming on your cell phone in a 24-hour period and a bunch of texting where you're getting confirmations with vibration alerts consumes less than 1% of the total power in your device. So if you have a concern about power consumption, you really shouldn't. And if you do a search for haptic battery consumption, you're going to find this white paper. This is how you can contact me and our company. I work with developers. I specify the effects that can go into their games. I do that for the big houses as well as the garage developers. And I like to review content. I'm a gaming guy as well as an application guy. So if you have anything you want me to check out, I'm happy to do it. Just let me know. Can I take some questions?
Actually, I think we have time, I guess, maybe for one quick question.
All right.
And the next person can start setting up.
Will this API support specialized devices that may utilize more than one vibration device?
More than one vibration device? Mm-hmm. So our API supports up to 32 devices.
Oh, nice.
So, yes.
Okay, all right. Thank you.
And actually, at the moment, I don't believe there are any devices that have more than one motor that I can talk about right now, but they will be coming. Okay, if anybody wants any of the quick start guides or my card, I've got them in the back of the room. And I appreciate your time. Thank you very much.